Okay, in this video we're going to explore the second packet in our review packets. This one mainly deals with fractions. So for 1a it says write an expression. Well, for one it says find an expression and find the total shaded area. Assume that the area of the largest square is 1. So this entire square is a 1, which means that the shaded area is 1/4. As we go to b, we have our original shaded area of 1/4, plus we have another shaded area which is 1/4 of 1/4, which gives us a 16th. So we have 1/4 plus 1/16, and over here we have 1/4. Let's look at this other one here for C. This is a 16th because it matches this one over here. Here we have another 16th. Here we have 1/4 of a 16th. This whole square is going to be 1/16 like these others, but we have 1/4 of it marked. That's going to be 1/64 because we just multiply the denominators. So 16 times 4 gives us 64. And then over here we have the same thing, 1/64. So for this one we have a 16th plus another 16th plus a 64th plus another 64th. Going to D, the larger block is a 4th. This block is a 16th. This block is a 64th. So for this one we have from largest to smallest, we have a 4th plus a 16th plus 1/64. Okay, so I'm not sure about what expression we can write, but we can see how, there's a pattern with the fourths of the fourths and the 4th of the 4th of the 4th, which gives us a 64th. Okay, let's move on up. Look at number 2. This whole area here is 81, and we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 triangles. So if the whole area is an 81, we have each one of these small triangles is 9, has a value of 9, and we have 1, 2, 3, 4 shaded ones. That's going to give us 36 units. In B, we've got 2 9s, which gives us 18 units. And then each one of these triangles now is divided again into 9 smaller triangles. So if this is a 9, 9 divided by 9 gives us 1. Each one of these is a 1. We have 1, 2, 3, 4, 5, 6. So we have 18, which is 2 9s for the larger ones. And then each one of these smaller shaded ones is a 1. That gives us 6 more. So this gives us a total of 24. Looking at C, all the small triangles are 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And each one of those is worth a 1. So we have 14 units in that one. Let's look at C. Let's move up. And see what we got. Okay, so I want to use the pattern. So let's see what they did. They took the square, the original 1, and divided it into 4s and shaded the diagonals, which is going to give us half of it, or 2 out of 4. This one has 0 out of 4 shaded. This other one has the 2 out of 4 shaded. Plus, we have 2. If one of these is a 4, then you divide 4 by 4, you've got 16. Each one of these is a 16th. We have 1, 2, 3, 4 16ths. So we have 2 4s plus 4 16ths. Let me do the last one, then we'll come back and simplify these. Looking at stage 3, we have 2/4 plus we have 1, 2, 3, 4/16 plus we have 1/4 of a 16th, which is 64th for these small ones. We have 1, 2, 3, 4, 5, 6, 7, 8 64ths. So let's see what we have totally here. This one gives us 0 for the area of the shaded. This one is half for the area of the shaded. This one is 2/4 plus 4/16. 2/4 can be changed into, if we have multiplied by 4, we have 8/16. So here we have 8/16 plus 4/16 gives us 22/16. Make sure I did that right. This is 8/16 plus 4/16 gives us 12/16, which is 3/4. So that one has 3/4 shaded. This one had 1/2 shaded. This one actually had 0 shaded. And looking at the third one here, we've got 2/4 and 1, 2, 4/16. So 64 is going to be the common denominator for these. So I'm going to put them all over 64. And 4 times 16 makes 64, so 2 times 16 makes 32. So 2/4 is the same as 32/16. It takes 4/16 to make 64, and 4 times 4 is 16. So 4/16 is the same as 16/64, and then we have 8/64. So when we add these up, we get 40 56/64. And we're not going to worry about the rule. We're just kind of worried about, how these fractions work out. Okay, then we won't worry about number 4. Let's go to the next page. So multiplying and dividing fractions. Remember, if we need to go for common denominators, so we might have to do that on some of these. Let me change the thickness a little bit and change up the color. So 1/4 and 1/4 is 2/4, which simplifies to 1/2. Let's do B. 3/4 and 1/4 gives us 4/4, which is the same thing as 1. 3/8 and 2/8 is 5/8, so that doesn't simplify. Here for D, we have to go for 64s for the common denominator. So 1 over 8 is going to be the same thing as 8 over 64, because I have to multiply 8 times 8 to get 64, so I do the same thing with the numerator. 8 times 1 gives me 8. And we have 8/64 plus 1/64, which is 9/64. Looking at E, 1/5 is the same as 2/10. So we have 2/10 plus 3/10 gives us 5/10, which is 1/2. Looking at F, 3 times 7 makes 21, so 1/7 is the same as 3/7 plus, or 3/21 rather, plus 2/21 makes 5/21. For G, we have to go for 15 for the common denominator, so we have to multiply the first one by 3. That's going to give us 6/15. And 6/15 and 2/15 is 8/15. Looking at H, we have to go for 64s. So we're going to have 8 64s, 8 over 64 for the first one. Times 4 is going to give us 12 over 64 for the second one. And then we have 5 over 64. So our denominator is going to be 64. And we've got 8 plus 12, which is 20, plus 5 gives us 25. So we get 25 over 64. Looking at I, 81 is the common denominator. So 9 times 9 makes 81. That's going to cause us to be 9 81st for the first one. 3 times 27 makes 81. That's going to cause us to be 3 over 81. And then we have 1 over 81. So our common denominator is 81. We have 9 and 3 is 12, and 1 more makes 13 over 81. Looking at J, we're going for 21 for the common denominator. So 3 times 3 is 9. We get 9 over 21 for the first one, plus 8 over 21 for the second one. That gives us 17 over 81 for the answer on that one. Looking at K, 8 is the common denominator. So we have 4/8 plus 2/8, which is the 1/4, plus 1/8. So that gives us 7/8 for the sum of those. Looking at L, we gotta go for 27. So 9 times 3 makes 27. That's going to be 9 27ths for the first one. 3 times 9 makes 27. That's going to cause us to have 12 over 27 for the second one. And then we have the 6 over 27. So altogether we have 27 27ths. Yeah, we have 27 27ths, which is the same thing as 1. So this 1 for that one. Okay, subtraction pretty much works the same way, except we're just going to be subtracting the numerators from each other. So let's look. 1 take away 1/4. 1 is the same thing as 4/4. So 4/4 take away 1/4 is 3/4. For B, gotta go for 16s. So 16 over 16 is the same as 1. 16 take away 3 is going to be 13. So we get 13 over 16 for B. Looking at C, 8 is the common denominator. So we have 8/8, take away 2/8, which is the 1/4, take away 3/8. So 8 take away 2 is 6, take away 3 gives us 3/8. So I did most of that in my head, but you can just kind of follow along. Looking at D, we got to go for eighths. So we have 8/8. A half is 4/8. So 8/8 take away 4/8 is 4/8. A fourth is 2/8. So 4/8 take away 2/8 is 2/8. And 2/8 take away 1/8 is 1/8. So we get 1/8 for that one. Here we're taking this whole group away from 1. So let's add up what's in the parentheses first. We got to go for eighths. So 4/8 plus 2/8 is 6/8, plus 1/8 is 7/8. So we have 1 take away 7/8. Now 1 is the same as 8/8. 8/8 take away 7/8 gives us 1/8. And then for F, we have 16 is got to be our common denominator for these. So we have 16/16, take away 6/16, take away 7/16. So 16/16 take away 6/16 is 10/16. 10/16 take away 7/16 is 3/16. So is 6. And we won't worry about G, H, and I. Let's go down and find these products for these others. Whoops. Let me go back. Sorry about that. So we want to actually move up. So let's look at, let's see, 1/4 times 1/4 is 1/16. We do numerator times numerator, denominator times denominator, and then try to simplify. B is going to be 3/25. C is going to be 1 over 27. D is going to be 10 over 24. Now both of those are even, so that's going to give us 5 over 12 when we simplify it. 2 times the 5th, with a whole number we have to figure out or pretend it's over 1. So we do 2 times 1 over 1 times 5. That gives us 2/5. And same thing with f. 3 times 1 is 3, and 1 times 6 is 6. We've got 3 over 6, which is the same thing as 1/2. For g, put 6 over 1. We do 6 times 2, which is 12, over 1 times 9. Now 3 goes into both of those. That's going to simplify to 4/3. And we leave it as an improper fraction. For h, put over 1. We're multiplying all these together. 3 times 1 is 3, times 7 is 21, and 4 times 16 is 64. For I, put the 9 over 1. 9 times 1 is 9, times 2 is 18, and 3 times 27 is 81. Now this one is divisible by 3. If I take a 3 out of the numerator and denominator, I get 6 over 27. Both of these are still divisible by 3. Take another 3 out of both, I end up with 2 over 9 for the simplified fraction for that one. Let's look at number 4. I must define the products. So half of 32 is 16, and we get, if we multiply it out, we get 32 over 16. We get 32 over 2, which is 16. Looking at number 4, put the 32 over 1. We get 4 times 8 makes 32. We get 32 over 4, which is the same thing as 8. For c, we get 3 times 32, which is 96, over 4, and 4 goes into 96 24 times, so we get 24 for that one. For d, put the 32 over 1. We've got 3 times 32, which is 96, over 8, and 8 times 12 makes 96, so the answer to that one's 12. Looking at e, put 32 over 1. Now here's how we kind of do some cross-canceling. I could take a 4 out of, I could cross-cancel 4 and another 4 out of 32. That's going to leave me with an 8 up there. And then this other 4 here, I can take out of the 8. That's going to leave me with a 2. So I've simplified all my numbers by cross-canceling, and I end up with 3 times 2, which is 6. And we get 1s in the bottom. So if you did that the long way and simplified, you're going to end up with 6. Here, put 32 over 1. Now 4 times 4 makes 16. 16 times 2 makes 32. So 32 over this 16 is going to end up with a 2. And I have a 3 times 3. So 3 times 3 is 9, times 2 gives me 18. So you can check it out. If you do it the long way, it's still going to come out to be 18. 4 times 8 is 32. So we end up with really 32 over 32, which is the same thing as 1. Here we have 8 times 8 is 64, so we got 32 over 64, which is the same thing as a half. So we get a half for that one, for h. For I, 8 times 4 is 32. Got a 32 in the numerator, so the 8 and the 4 are going to cross-cancel out with the 32, and that's only going to leave me with a 9. Okay, let's go on to the next page. Let's go to the next page here. Okay, you want to find these products. So, and we got some rules of exponents coming on. We'll talk about those as we go. So 3 times 3 times 3 is 27. Change colors. Just going to get 27. 4 times 4 times 4 is 64. And 2 to the 5th power is 32. 5 times 5 times 5 is 125. 10 times 10 times 10 is 1,000. With powers of 10, you can just put a 1 down and count the zeros. 2 times 2 times 2 times 2 is 16, so in the denominator it's going to give us 1 over 16. 7 times 7 is 49, and 49 times 7, remember that one, gives us a 3, carry a 6, get 28, 3, 43. 3 times 3 is 9, times 3 is 27, times 3 is 81. For h, we get 1 over 81. And then 6 times 6 is 36, times 6 is 216, times 6, 216 times 6, gives us a 6, carry the 3, that gives us a 9, it gives us 1290, no, 1296, 1296. That's what we get for those. Okay, here we want to write these in exponential form for part number 2. So the base is 3, and the number of 3's multiplied are 4, so that gives us 3 to the 4th power. It's the base to the power. Looking at the 4's, 1, 2, 3, 4, 5, 6. That's going to give us 4 to the 6th power. 1, 2, 3, 4, 5. 2 to the 5th power for C. 5 to the 3rd power, 10 to the 3rd power, 1/2 to the 4th power. And I put parentheses around the 1/2 because it's 1/2 times 1/2 times 1/2 times 1/2. So the half is the base, and it's multiplied 4 times. G, 7 is the base. We get 7 to the 4th. Here we have 1/3 to the 4th power. And here we have 6 to the 5th power. Let's move up. Rewrite as a repeated multiplication. So this is 4 times 4 times 4. 4 times 4 is 16, times 4 gives us 64. 2 to the 6th, 2 to the 5th is 32, so 2 to the 6th is going to be 64. It means 2 times 2 times 2 times 2 times 2 times 2. This means 6 times 6 times 6. That's going to be 36 times 6, which is 216. This one was 64. 3 to the 6th. 3 times 3 is 9, times 3 is 27. So we end up with 3 times 3 times 3 times 3 times 3 times 3. I'm going to basically use these 3's, which is 27, times the next 3's, which is 27. So 27 squared is going to be the answer. 7 times 7 is 49, carry the 4. We get 14, and 4 gives us 18. 2 times 7 is 14, carry the 1, and we get a 5. So we get 729 for 3 to the 6. Now for 11 squared, get 11 times 11, which is 121. For 10 to the 6th, you get 1, 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s all multiplied together. That's going to give us a 1 with 1, 2, 3, 4, 5 with 6 zeros, which is going to be 1,000,000. 2 to the 10th, 2 times 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 2. And 2 more, times 2 times 2. Let's see. Well, 2 to the 5th is 32. Another 2 to the 5th is another 32. So as a shortcut, if I do 32 times 32, I think I'm going to get 1024. Let's see. So we get a 4. We get a 6. We get another 6. And we get a 9. So we got a 4, a 2, 10. So 1024. 1/3 to the 3rd power is 1/3 times 1/3 times 1/3. 1 times 1 times 1 over 3 times 3 times 3 gives us 1 over 27. And 2/3 to the 2nd power, that's 2/3 times 2/3. We get 4/9. Okay, so that's those. Let's see what we got for the next part here. Let me move up. Write each number in exponent form. So I just know that 32 is the same thing as 2 to the 5th. 27 is 3 3's, that's 3 to the 3rd. 64 could be 2 to the 6th. Or we could think of it as 8 squared. Or it would be 4 to the 3rd. So those are all possibilities for that, for 64. 81 is 9 squared, but it also could be 3 to the 4th. 289 is 17 squared, and 1331 is 11 to the 3rd. I guessed and checked this one in the calculator is how I found that one. Okay, here we want to add fractions with unlike denominators, so we have to go for a common denominator. So between the 4 and the 3, I see 12, so I have to put everything over 12, and it's an addition problem. So 3 times 4 makes 12, so 1/4 is going to be the same thing as 3/12. 4 times 3 makes 12, so 4 times 2 is going to be 8, so 2/3 is the same as 8/12. That's going to give us 11/12 for the A1. Here we're multiplying. We get 3 times 16 is 48 over 8. I could have cross-canceled and simplified it, but basically we're going to get 6. Okay, for 5, 6, take away 1/4. The least common multiple is going to be 12 for these, so I have to put them both over 12. And 2 times 6 makes 12, so I do 2 times 5, I get 10. And we're subtracting. It takes 4 times 3 to make 12, so 3 times the numerator is going to be 3. 10/12, take away 3/12 gives us 7/12. Looking at number or D, the common denominator is going to have to be 8 for these. So 8 times 9 is going to be 72. So 9 is the same thing as 72 over 8. And we're taking away 3 over 8. That's going to give us 69 over 8. For E, looks like 35 is going to be our common denominator. So I have to put everything over 35. The 4 is originally over 1. So 5 times 7 makes 35. So I have to do 5 times the numerator. It's a times. Oh, this is a multiply. So forget the common denominator stuff. We're just going to multiply these out. So 3 times 4 makes 12. And 7 times 5 is 35. So we get 12 over 35 for this one. If we were adding these up, we'd have to go for the common denominators. And then F, 64 is going to be the common denominator. So 7 is already over 64. We leave it. It takes 4 times 16 to make 64. So 4 times 5 is going to be 20. We get 20 over 64 for the middle one. And 8 times 8 makes 64. 8 times 3 is 24. We get 24 over 64 for the other one. They're adding all these together. So 64 is our denominator. And we have 20 and 24, which is 44, and 7 gives us 51. So we get 51 over 64. Let's move up. On this one, we need to use a number line to check this, supposedly. I don't know. The main thing on this one is, okay, 12 take away 5, if you do plus opposite. 12 plus a negative 5, we got two different sign numbers. The rule with different signs numbers is you keep the sign of the biggest. And you subtract. Now if the signs are the same, G and S, you keep the sign and you add. And I'm going to end up turning all these subtractions into addition of the opposite. So I'll just do that right now with all of these. Any subtractions, I'm going to do plus opposite. So I've taken care of those. Now these are all addition problems, and I just have to do it with the sign numbers. So 12 positive is going to be the outcome, and the difference is 7. Negative is going to be the outcome, and the difference is 7. 15 is going to be positive, and we're going to end up with a positive 9. 15 and 6, keep the signs, add the numbers, we get 21. 2 negatives gives us negative 10, and positive 7 with a negative 3 is going to give us a positive 4. Let's move on. Okay, here we have some PEMDAS problems. Remember, we do multiplies and divides before we do adds and subtracts, after we do exponents, or parentheses and exponents. So the 4 times 8 has to be done first, or 4 times 2 has to be done first. That gives us an 8. So we have 9 take away 8 plus 3. 9 take away 8 is 1. 1 plus 3 is 4. Over here we have to do the 12 times 3 first. That's going to be a 36. So we have 9 take away 4, which is 5, plus 36 gives us 41. Over here we have to do the negative 3 times 6, which is negative 18 first. And then we have to do the 4 times a minus 5, which is a minus 20. And we end up with negative 18 plus a negative 20. That's going to be negative 38. Looking at D, we have to do the negative 6 times the negative 2 first. 2 negatives make a positive, so it's going to be positive 12. We have a negative 18 plus 12. That's going to be a net result of negative 6. And a negative 6 with the 5 gives us a negative 1. Here we do parentheses first. 9 take away 18 is a minus 9. But 2 times a minus 9 then is going to be a minus 18. I missed a plus opposite. So we have a minus 18 plus 10 leaves us with a minus 8. Over here, this last one, parentheses first. 5 take away 9 is a negative 4. But we got the opposite of a negative 4. That's going to be a plus 4. 4 times negative 3 is negative 12. And we're adding a negative 6 times a negative 2, which is a positive 12. That gives us a 0. Let's move up. Do the following calculations. So, multiplies first, we get a negative 14. 3 take away 14 is negative 11. Take away 5 more is negative 16. Parentheses first, a negative 4. Negative 4 times 2 is negative 8. Negative 8 plus a negative 5 makes negative 13. Here we get a negative 4. On the other side, we have a negative 3. So we end up with a negative 4 times a negative 3. That's going to be a positive 12. Looking at D, we have to do the 2 take away 5. This is going to be a negative 3. We've got to do this multiply. Negative 7 times negative 3 is positive 21. Positive 21 plus 3 gives us 24. Looking at E, let's see. Inside the parentheses, we do multiplies and divides first. So negative 7 times 2 is going to be a negative 14. A negative 14 plus a negative 5 is a negative 19. So we have 3 plus a negative 19, negative, and then 19 and 3 gives us 16. So we get a negative 16 out of that. Looking at F, a negative 7 times 2 is a negative 14. 3 plus a negative 14 is a negative 11. A negative 11 take away 5 is a negative 16. Now this recursion, you might not remember doing these for a while, but you start with an initial value, and then you take the answer and you keep plugging the answer back in as many times as it says to do this. So they want us to do this 3 times. They want us to start with a 2. So 2 is going to go into that first, and we have half of 2 take away 1. 2 take away 1 is 1. Half of 1 is 1/2. So we get 1/2. Now the recursion says we're going to do 0.5 times 1/2 minus 1. Now that's going to be a negative 1/2, and a half of a negative 1/2 is a negative 1/4. That's going to be the second time. Now negative 1/4 goes in, and we have 0.5, that should be 0.5, times negative 1/4 minus 1. Now negative 1/4 times 1 minus 1 is a negative 1 minus 4/4, which is negative 5/4. And half of negative 5/4, 1/2 of negative 5/4, we can multiply, we get negative 5/8. So that's our third. So there's our recursion 3 times. We started with 2, took the output, put it back in, got negative 1/4, took the negative 1/4, put it back in, and we got negative 5/8. And do 3 more. We won't worry about these others. And this attractor value they're talking about is like, what ultimately does it seem like it's going to end up going to as you do more and more of these? There's going to be maybe some value that it seems like it tends to go to. Like this one here, looks like it's kind of, if this continues, we got negative 5/8, negative 1/4. It looks like it's going to get closer and closer to negative 1. Is what my attractor value would seem to be for this one. Let's look at the next page. And we're done.